haw, hee hee haw. Oh, I mean e-learning. It's been 5 weeks since our quarantine started, and came the day we had to stay home. And your kind smile I've missed since we parted, but you miss my tie flips 1,000 times more. Where, oh where are you today? Why did you leave me here all alone? I searched the world over and thought I found students, but they closed the schools and we was home. Happy Friday, everybody. I got myself cleaned up. That was the first time I've ever had a pie in my face. And I tell you, you know what the worst thing about having a pie in your face is? It never ends. 3.14152653589793238462643384626433832795028. And it goes on and on and on. In fact, on Monday, when I was driving into school, we can only go into school, the teachers, for a few hours on Monday. When I was driving into school, there wasn't hardly anybody on the road, but I noticed that the police officer pulled Mr. Pie over. And then I thought to myself, I guess Mr. Pie, he doesn't know when to stop. So, hopefully you enjoyed that. And so it is Friday. For those of you in math counts or want to do an online competition, we have one this morning at 11 a.m. It will take a half hour max out of your time. It starts immediately at 11. And so we are in the Elite 8 in the country. And last week was quite a barn burner. I was stressed out. I was turning my hair gray. But we need you and we need your score. And so here's the bracket. We're going against Indian Valley, I think, Eagles of Harleysville, Pennsylvania. The population, I have no idea. But it could be a tough one. And if we win, if you see the bracket, we're going to be in the Final Four. And that will be next week. And I don't know if my heart can take this much more. But you guys are doing a great job. And it makes a little fun and excitement to be in the big dance. And so make sure, if you want to be a part of that and you've never done it before, I will send you a username and password. And you just click on this on our school page. Just click on Online Math Counts Competition Day. You're all invited. Click on that, and we're glad to have you. So, the attendance form is right here. Make sure you are completing that. This week's attendance closes out on Sunday night. Monday morning, we will have next week's attendance. You need to finish the attendance for this week before Sunday night. Every once in a while, someone goes, I can't take attendance for last week. That was last week. This is this week, so make sure you get that done. So right now, pause the video, take this attendance before you forget, and then we'll get right back to you. So get the attendance taken. Let's see what we have in store for geometry today. And so we did the composite mappings that you sent. That was a 3-page handout you completed, and so great job, everybody. But don't forget to be doing the Khan Academy stuff. There's warm-ups. 3 every week. You need to look. You can do the past ones if, I forgot some. Get those done. But just get those done for this week because you're getting 3 new ones next week. Okay? And so as we scroll down to geometry today, we're going to talk about inverse and identity transformations. And so we want to get the warm-ups, the logic problems. They were due last night, so hopefully you got that done. Many of you did. Great job. And so we'll get you the results on those hopefully soon. And let you know how we did. And so, but tonight's homework is assignment number 118, page 607, 1 through 26. Okay? And so let's talk about what we're going to do today. So this is notes 118. We're going to talk and remind you of inverses and identities. And so write notes 118 in the corner. I could write it and then just erase it, but write 118. And so we're going to talk about identity and inverse. In algebra, when we talked about the identity, when it came to multiplication, if you had A, what do you multiply A by to equal A? What would that be, Carissa? Yes, it'd be a 1. And so A times 1 is A, which is also, since multiplication is commutative, 1 times A is A. Boy, that's not that earth-shaking. But then remember when we took those property quizzes that when you do the inverse The inverse is what do you multiply A by to get 1? And what would that be, Megan? It'd be 1 over A. Yes, it's reciprocal. It's multiplicative inverse. Boy, that's a mouthful. Or it's reflipical. But the thing is, how did we used to write 1 over A? That would be the same as A to what power? Well, it'd be A to the negative 1. And so we had A times A to the negative 1 equals 1. And we begin to call this the inverse. And we not only did this when we were talking about multiplication, and this is called the multiplicative inverse, but we also, when we were doing trigonometry, remember SOHCAHTOA and everything, we had the sine function. And if you wanted to need the inverse, we called this the sine inverse, the inverse sine when we were finding the angle. And so that was the inverse function. And when we do function notation, you have f of x. And f of x, the number goes in, and the number comes out. But if you wanted to reverse the function and go the other way, we wanted the inverse function and be f, and we put a little negative 1 there. And so we kind of stick with this inverse notation, how to undo what we did. And the same thing's true when it talks about transformations. You could have a transformation. Now your book says you have a transformation S. Maybe we're flipping it. And then we call the big R, reflection. Maybe it's a rotation. Maybe it's a translation. Maybe it's a glide reflection. But any S transformation, if you wanted to do something to it that didn't change it, we'd call it the identity mapping. And keeping with the function notation, it's kind of an open dot there. And so anytime you do an identity mapping, you didn't really move it. It stays the same spot. And so you might have done some things, but it ended up where it started. The inverse mapping is you do a transformation, and what transformation can I do to it? That would be the inverse transformation. And then that would equal the identity. And so the same ideas. That's why these mathematical ideas, once they are in the brain, they're there forever. You're going to get A's in all your classes for a long time, as long as you keep doing your work. Hopefully we can soon get back in school one of these years. And so, but we want to make sure that the mathematical ideas are there. Once they're there, they're always there, and you'll do a great job in class, SAT, all the above. Okay? So let's talk about a few short examples that we have in this next set. And so right here it says a rotation. Now remember in the book, if they have a nice fancy cursive script R, it's going to mean a rotation. And if we have 60 degrees, would that be clockwise or counterclockwise? And the book's sometimes nice to you because it will even tell you it's counterclockwise. Because remember, a positive rotation goes this way. And a negative rotation would go clockwise. And so remember that. But this says that a rotation is a 60-degree counterclockwise rotation. So one rotation, if this is a hexagon, 360 degrees, and these are equilateral triangles, remember, going between here and here. So each of these are 60 degrees. So that means the arc length is 60. So one 60-degree rotation is just going from here to here. Two 60-degree rotations goes from here to here. So if we start at Z and we rotate, this just means two rotations. It means, if I could make a cursive R with a mouse, ooh, that's not that good. That means rotation composed with a rotation. That means we're going to do two of them. Well, that means that's going to equal point X. If we did four rotations, a 1, a 2, a 3, a 4, that means we're going to end up at V. If we had 6 rotations, a 5, a 6, see, we end up back where we started. And so 6 rotations would actually be like an identity. But we wouldn't write point. If they just want the point, you just write Z. But that is like an identity mapping. We ended up back where we were. It's like we didn't do anything. We went and said, well, I'm end up right back where I was. 7 rotations is actually equivalent to 1 rotation. And so that would be a y. 3 rotations, 1, 2, 3, would actually be the same. Well, it is point W, but it's actually the same as 3 negative rotations. And so this is an equal sign. And so R in this problem, this doesn't mean it's always true that 3 rotations equal negative 3 rotations, but 3 times 60 is 180 degrees, and that's half of 360. 1 rotation in the negative direction would be 5 rotations in the positive direction, which is just this problem right here. And so if we go 1 in the negative, what letter would that be? Grant? U. U is correct. See, they always say you are correct. But U is the answer, and U is correct is the correct way of correctly speaking English instead of you are correct. U is correct. Yeah, you are and U is. And so those are both U. Same thing here. R to the negative 6 would still be R to the 0, which would be a Z. R to the 12th, since that's a multiple of 6. What would that be, Jacob? Are you still working on your logic problems? Oh, no, they were done last night. And so, are you starting your homework early before we finish the notes? Just like in class sometimes. And so that would also be a Z. What would R to the 30th be? Camden? Oh, since that's a multiple of 6 also, that would still be a Z. Oh, yeah. Look how fast we can do them. 3 rotations to the right, 3 rotations to the left, to the right, to the right, to the right, to the left, to the left. Oh, we're ended up right back where we were. And so that's going to be a Z. And then R to the negative 2, 2 rotations clockwise would be the same as 4 rotations counterclockwise. And what answer would that be? Carson? Yeah, Clemens. Which one would it be? That'd be a V. Very good. And so lots of things there. Not too tough. Just simple knowledge. Get in the head. Doesn't have to be hard to be important. Just make sure we get that. And so this next part on here, this goes really fast. How do you undo adding 6 and adding 1? How do you undo multiplying by 4? How do you undo subtracting 1? How do you undo dividing by 5? How do you undo dividing by 5? Let's see if we can get this in popcorn fashion. Jerry, why do you undo adding 6 and adding 1? Very good. Subtracting 6 and subtracting 1. Good job, Jerry. Did your mom tell you the answer? Oh, you got it on your own. I believe you. I believe you. The second one, 4x. How do you undo that? Adela, divide by 4. So you can just write x over 4. You don't have to write 1/4 x. And then Adela, how do you undo subtracting? Well, if they subtract, we add. She's such a rebel. And so y plus 1. This next one, what would be the inverse? And we could say S inverse colon would equal, and this would be S inverse, and this would be S inverse. What would this one be? Charlie? 5x, 5y. Yes. See, we have to know who's paying attention. This is an S, and these are 5s. They're not all S's. They're not all 5s. That shows you're paying attention. What about over here? If they add 3 and you just have a y, what would this one be? Kirsten? Yes, subtract 3. But then if you don't do anything to y, you don't do anything to the y. Elaine, what if we were going to do it twice? What would it end up being? If you're going to subtract 3, if you were going to undo this one, well, here we're not undoing it. If we were undoing it, ooh, I almost made a mistake. There'd be a negative there. So we're not undoing it. We're just going to translate this twice. So instead of adding 3, Eileen, what are we going to do? Yes, very good. We're going to add 6. So that'd be x plus 6. But notice the y doesn't change, so that stays a y. Here, the translation is we're going to go 2 to the right, and we're going to go down 5. 2, 3, 4, 5. And it says we're going to do it twice. So what would that transformation be? Beachy? Yes, that'd be adding 4. So it'd be x plus 4. And then it'd be subtracting 10. So it'd be y minus 10. And then this last part, if ry is a reflection of the y-axis, what do you get when you flip across the y-axis? Whoa, we'll go this way. When you flip across the y-axis, and then you flip back across the y-axis, well, that'd be the same as the identity mapping. You end up right where you are. Okay? So instead of assigning the hardest problem on your homework, we're going to do the hardest one together. So, okay? So let's talk about the last one together. This last one is kind of a proof. Don't be scared. We're going to do it together. I could assign it on the homework, but we're just going to talk about it here. It actually is problem number 30. And so the picture's in your book on problem 30, but I put it right here on the notes. And so let's just talk about this problem. It says prove that a half turnaround A composed with a half turnaround B composed with a half turnaround B composed with a half turnaround A ends you back up where you started. And so you're like, why do I care? But let's talk through it. It's the experience that matters. And so we're going to start right here with Mr. Astronaut floating out in space here. And so if we have Mr. Astronaut right here, and we're going to spin him first around A. So here's A, and he's going to spin up here. There he is. Then we're going to spin him around B. Well, then he'd go down here. Well, if you look, is there an easier way to write that? Well, yeah, that'd be the same as just sliding him to the right. So all of this simply is just a translation T. Here, let's take the astronaut from the beginning. And instead of spinning him around A, because this is the one we do first, let's spin him around B first. So this was the homework we did on Wednesday. He ends up being over here. Then this is the one we do second. We're going to spin him around A, and then he ends up being over here. Well, if you look at the beginning, where did he end up? He just ended up at S. Now, why is translation T composed with translation S the identity? Well, if you look at it, translation S is exactly the inverse of T. It's the same distance, it's parallel, exact same direction, and so S is really the inverse of T, and an inverse composed with, it's not inverse, always ends up with the identity transformation. So that is a proof of doing that. Now, there's another way you could prove it without ever looking at the picture, using your properties. And so I have a half turn of A, composed of half turn of B, composed of half turn of B, composed of half turn of A. Oh, we could use the associative property and just put the parentheses around half turn of B composed with a half turn of B. Well, a half turn composed with a half turn is a full turn, and a full turn gets you right back to where you started. I just remembered the song. Back where I started from, where bowers of flowers bloom in the sun. Each morning at dawn, sun-kissed miss said, don't be late. I can something hardly wait. Open up that golden gate. California, here I come. I think Fred and Ethel Mertz sang that on I Love Lucy. I really do. But a half turnaround B composed with a half turnaround B is the identity. And then a half turnaround A composed with the identity, composed with a half turnaround A. The identity is not really there, so it'd really just be a half turnaround A composed with a half turnaround A and a half turnaround A. Whoop, gets you that far. And then another half turn, get you right back where I started from, where bowers of flowers bloom in the sun. Each morning at dawn and sun-kissed miss said, don't be late. And a half turnaround A and a half turnaround A get you to the identity, which is right back where I started from. So, well, that's the proofs. And Now let's look at the homework. And so the homework today, I'll put myself back down in this corner. And there we are, get the sound off my face. Don't be doing the class exercises. I almost did that. That's no good. You want to do the written exercises. And so the written exercises right here, just remember, copy the problem down. 4 to the negative 1 power is 1/4. Just the reciprocal, the multiplicative inverse, the reflipical. And 9 to the negative 1. Remember when you have a fraction to the negative 1, you just flip it over. Remember on number 4, a power to a power, you multiply. And then we get to these. Rotation arm maps everything 90 degrees. Remember, 90 degrees, if we start at A, is counterclockwise. It's a positive rotation if you're going counterclockwise. So in problem 5, you can write the script R, the cursive R. And if you want 2 rotations, you go 1 and you go 2, and that'd be a half turn. And that'd end up being at C. 3 rotations, well, that would end up at D. And if you did 4 rotations, you'd get right back where I started from, where bowers of flowers bloom in the sun. Da 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 da. Sun-kissed miss said, "Don't be late. I can hardly wait. Open up that golden gate, California. Here I come." But not on a travel ban. No California, here I come. But maybe later. And then fill in these. The inverse of a half turn is a half turn. 3 half turns equals 1 half turn. And then when you get to these next ones, you have, what are 2 translations? Well, if you go 2 to the right and you do it again, you're 4 to the right. And you can get those. And then the last ones here, just undo them, just like on the notes. And I should have assigned problem 27. I don't know why, but it says if you're going to go right 12 and then down 3, what would happen if you did it 6 times? Well, 12 times 6 would be 72, and 3 times 6 would be 18. So, but the assignment's just to 26, so you're good. Remember the competition, 11 a.m. to 11:30. We need you. And so it's really going to be exciting. And so we might make it to the final 4. And so if you have any questions, let me know. Homework today should go fast. And so hopefully you enjoyed the video. And we look forward to seeing you on Monday. And just let me know if you have any questions. So I look forward to answering your emails and receiving your assignments. So have a great day, everybody. We miss you.